Our manifolds that we're going to use for the turbo setup are in, and we're very happy with them in the way they are. But there's a little bit of casting flash on the turbo side, right here, and up in here, and up here. This is the area where the spark plugs go. So we're just going to take a couple minutes, and we're going to use our carbide bits, and we're just going to clean this up a little bit before we move on. Today we have a little dilemma we have to deal with in our Trailblazer SS turbo install. Curveball, if you will. To save money on the whole project, we decided we were going to build our own turbo kit. And for the hot parts for the exhaust, we went and we got a kit off of eBay because it said that it went for the Trailblazer SS. And we had a precedent for this. We had a 2005 Silverado pickup truck, 1500, that came to us with these hot parts already on it, and they worked okay, they seemed okay, so we thought they would be a good way to save a couple dollars on the basic stuff that they were just manifolds. But despite them, the ads on eBay advertising that they fit Trailblazer SS, these manifolds clearly do not. Seemingly we've made a poor choice on the exhaust hot parts. And let me show you those hot parts. These are the manifolds that we got. This is the driver's side, and this is the passenger side. They both have very bad fitment issues. The driver's side puts this flange right where the steering shaft of the Trailblazer SS is. This is a pretty big issue all on its own. The passenger side is really tall off of the engine and interacts with the passenger side strut tower. And that is a whole nother problem. To recover this, we're going to get rid of this. We're not even going to use this. We're just going to we're going to get the factory cast LH manifold for Trailblazer. It actually has a very similar, if not the same, exhaust flange on it. And so we hope to be able to just chop and re-weld our transfer pipe and make that work and fit just fine. The one thing we do need to make happen is we need to make this fit in the Trailblazer. And so we only have to worry about modifying the passenger side of the vehicle at the strut tower. And let me show you what that looks like. I've traced out in orange the area where the material is that I need to remove from the strut tower. The strut tower is largely hollow right here anyway. We just need to open it up a little bit more so the manifold has room to fit. To make this happen, we'll remove the shock, we'll remove the upper control arm, and after we cut away, we'll replace it with, we'll plate it with steel and we'll weld it in. I don't know if I'm going to pull the engine out to do this. I've given a lot of consideration to this. We have a fiberglass welding blanket that we might just lay over the engine, and then to cut down on metal shavings, I might trim this out with the plasma cutter and see how that goes. Of course, if the motor has to come back out for it, that's exactly what will happen. But I think I can do all my welding from inside the pocket with the suspension pieces removed, so I'm not even really welding out here where the engine is. And we'll see how that goes. It's a little curveball. We want to try not to let this slow us down too much on the whole build, but it is what it is. All right, here we are. We got the LMF motor all buttoned up so that there's no opens to the inside of the motor, just in case any debris wants to fly around underneath our fire blanket. Here we are with the welding blanket covering the engine, and on our strut tower where we're going to cut, we ground all the paint off to make it easier for the plasma cutter to cut through the metal. The plasma cutter needs an electrical connection, so it'll always cut through clean metal a lot better than it'll cut through painted metal. Furthermore, this strut tower is 2-ply. There's 2 pieces that are at the same distance from each other up here where the weld is, but then they grow out apart from each other. So all this material that we're about to remove, I don't think we're going to touch the outer wall of the strut tower. And then we can just reinforce on this side and on the back side of it, and I think we'll be just fine. The best advice I could ever give anybody about running the plasma is don't cut freehand. The more you booger up your cut, making your cut, the more prep you're going to have before you can weld or do anything with it. The best way to use a plasma cutter is with a guide. You draw out your line on where you're going to cut if you want, but then you use a physical guide and you run your tool along the guide. You hold the guide along the line about 1/2 inch above it, you figure out where it's going to be, you figure out where it's going to go, and then you make your cut tracing the guide. And at that point, the only thing that really matters is that you're holding a consistent speed, and that's pretty easy for anybody to do. But when we make straight cuts like that, we land with something that is much easier to clean up and move on with before we're done. We've already made all of our cuts, and we're real happy with the way it came out. We're using these little wedges as wedges to knock it out and punch it out. And that's where we're at. Okay. This is the amount of material that we removed on the first go. Now we're going to try to test fit and see what we get. All right, well, that first cut from the strut tower gave us all the room we needed. The manifold lines up on the head just nice. We got a little bit of a gap between the strut tower and the manifold, and everything would be great that way. But the next problem we bump into is now the flange for the turbo is going to interact with the strut tower. You can see right here, the manifold still needs to go back about a whole inch, but we're right here. This is going to be a problem because the turbo is going to hang off this side, it's going to hang off this side, it's going to be in the way. So I'm pretty sure the next step here is we need to modify this manifold. And good thing we got a welder. It's cast. It's our exhaust hot parts is proven to be quite the challenge. For the driver's side, we're going to use the stock Trailblazer SS exhaust manifold that's cast. It hugs the block and clears the steering shaft, so we don't have to make any changes there. And it was cheaper than it was so cheap. It was well worth getting that part. It even comes with a nice heat shield on it. This passenger side is really incompatible with this truck. So we've drawn out some lines where we plan to cut. We're probably going to chop it right here around this bottom line and just remove this altogether. And we'll get another section and we'll weld it on. For welding cast iron, there's a couple of tricks to the trade to welding. Some guys will tell you you got to superheat the cast iron and preheat the shit out of it, and then you got to use a special wire, and then you got to let it cool down very slowly. Some people tell you need to bury it in sand, and there's a bunch of different ways around it. One way where you don't have to do any preheating is you just do very small bits and you let it cool all the way back down, and you don't ever get it hot, because the problem is the fast cooling off that helps it to crack. And so a lot of times you can just do very small sections, peen it, and then let it cool completely to the touch before you do another very small section, and use nickel rod or something, and you can make it happen. We might be stuck trying that with this. And furthermore, this is a 2.5 inch ID dimensions. I might try and get a steel thin wall T4 flange to weld onto this cast to try to make it. I might even be able to relocate the turbo, put it in a better place, put it out in front of the motor and set up on the side. You know, we'll have some options there, but that's for the next video.